Hi, good afternoon, everybody. We're going to start in just a minute. We're waiting for a few more people to join the meeting. Well, good afternoon, everyone. Thank you for joining our Wireside chat with Ketson Networks. My name is Dan Lorenz. I'm the Director of Vendor Relations for CTI Connect. And today we're going to be meeting the folks from Ketson Networks who have an innovative 60 gigahertz point-to-multipoint and meshing technology. So before we get started, I'd like to have you all answer a poll for us. We want to gauge the audience's experience with 60 gigahertz technologies. So if you could go ahead and answer that poll. And while we're waiting on responses, I'm going to go ahead and introduce the Ketson team. With us today, we have Dave Island, who's the Vice President of Sales for North America. We have Chad Dewey, who is the Senior Vice President of Engineering, and we have Bryce Barand, who is the Vice President of Software. Taylor, can you put up the poll results? Okay, well, we got a pretty good mix of answers here. Some people who have deployed it, some only use it for point-to-point, and about a third of us have never tried it before. So that's a pretty good blend. We can talk about the different applications for the Ketson product, where it fits, and how it's different from some of the other products in the market. So I'd like to go ahead and introduce Dave Island, Vice President of North American Vice President of Sales, who's going to give us a quick overview on the market opportunity and what Ketson does differently.
Great, Dan. Thanks for having me. Welcome, everybody. For those of you that have not heard of Ketson, I thought I'd talk a little bit about Ketson, how we got here, and what we're going to talk about today. So Ketson spun out of a company called WeLink. If you're familiar with WeLink, WeLink's a WISP that is here in the US, deployed in several cities across the country. And WeLink wanted to use a 60 gigahertz band and develop their own radios to do that. And that they've developed their own radios, and they've deployed now over 20,000 subscribers that are actively deployed on the technology. So as that has grown, they've decided to take that technology and spin it out into a separate company, and that is Ketson. So Ketson, although we're new to the market, we have a lot of water under the bridge and a lot of subscribers deployed. And I think what makes our technology different and unique is that it comes from an operator perspective. Because it was built and engineered as an operator, our tools and our software and our radios are built as an operator, from an operator's perspective. And I think as we go through today's exercise, you'll see that shine through. I throw up a little opportunity slide here, and I want you to see that we're attacking the higher density residential broadband marketplace, and that's single family residential, multifamily dwelling, small to medium business. And we do that because that's where the people are. And that's where the opportunity is for growth. And that's where the opportunity to make money. And what I found is even the most rural WISPs, there's part of the network that's near the density where Ketson shines. And so, as WISPs have grown and evolved over the years, they kind of always shied away from cable and fiber. And our solution gives you the opportunity to attack fiber, go after if a fiber provider is there or a fiber provider enters an area where you serve or near where you serve. With Ketson technology, you can compete head up against fiber and win. That's what WeLink's done, and that's how we can take Ketson technology and allow you to win. And with that, I'll kind of turn it over to the next poll question.
Right, that was a good summary, Dave. We'll give folks a moment to answer the poll here.
There's definitely competition out there. So we want to enable our customers to meet that competition head on and win head to head.
Yeah, like you pointed out, even the most rural WISP has a small town in its footprint, right? There's always somewhere where there's some population density, even if you're the main part of the network is in the wide open spaces, farmland or whatever. There's always a town somewhere, right?
Exactly.
So, yeah, Taylor, go ahead and throw up results if we have them.
All right, a lot of fiber.
Yeah.
So that's on point.
Yeah, that's interesting to see that there's not as much from T-Mobile and Verizon because, you see a lot of that in the media, how their FWA products are just growing leaps and bounds, but apparently not so much with our audience. I mean, 17% is significant, but not the number I expected to see on that poll. So
I think that might be because it's where areas where our customers may not be. But everything's evolving.
Yeah, right. So let's hand it off to Chad. Chad is going to give us a little bit of the hardware overview and talk about the different components of the Ketson system. It's really just a handful of radios and things, but it's really interesting the way it works. And then we'll after Chad, we'll hand things off to Bryce, who's going to talk about your management software and planning software and so forth. So Chad, go ahead.
Absolutely. Go ahead and skip to the next slide here. We'll go one more too. Awesome. So this is kind of what we would call kind of a bread and butter deployment for Ketson. So we can take one fiber point or we can take multiple fiber points, and maybe even fiber is the wrong word here, right? But point of presence. And we can essentially build a 60 gigahertz mesh kind of layer 3 redundant network between multiple fiber points. So that's our core focus and what we've built out. And what you'll see, so this is about 2.5 square kilometers. We're passing 1,000 homes. We pass or provide coverage to 97% of the homes throughout that given area. So it's how do you go into these dense areas and provide deployment is certainly, to Dan's point, kind of what our specialty is. And what you'll kind of notice here, if you look, there's kind of some darker lines that kind of run through here, and it's creating a layer 3 ring throughout that topology. So both that ring or the infrastructure layer and the access layer are both on 60 gigahertz today. And we do that with a Peraso-based wireless system, and then our own kind of outdoor hardened layer 3 router that goes at those infrastructure sites, or those sites that basically kind of repeat and extend the signals. So with that, you see we post speed tests here of what we see in real life networks. So our launch partner, WeLink Communications, they offer speeds of up to 2 gig, 1 gig, and 500 meg are the speed tiers that they offer. And it's absolutely what the platform is kind of built to support. We can go one more slide, Taylor. Awesome. So we do this with kind of 4 devices. What David or Dan had commented on. the core piece is that core fabric router. So it's an outdoor hardened layer 3 switch that does all of the routing on your behalf. So it's doing hello messaging every 50 milliseconds, sorry, 500 milliseconds, and doing session by session routing across the mesh for both all like CPE, CN customers, but then also those infrastructure customers. It's also an outdoor hardened mid-span PoE switch as well. So it's easy to take that and deploy it exactly where you need it. So if it's a street light, if it's a customer home, if it's a tower, that switch basically gets deployed with the wireless gear. You deploy the DC power to it, and it handles both the configuration, the routing, and the wireless configuration as well through that single point of management. We have 2 wireless pieces, sorry, 3 wireless pieces, but we have 2 what we call like mesh or infrastructure wireless, which is a 4-inch point-to-point radio and an 8-inch point-to-point radio. So depending on the distances required, we find the right wireless piece for the job. And then we have an access radio that does broad coverage to go and bring CPEs in from the given area. So that's kind of the quick piece on it. The nice part here is, and what Bryce will touch on a lot of the software, but we really focused on simplicity, redundancy, and modularity. So having the wireless pieces broken out separate from the routing means you can go to a commercial rooftop, and you can go on different corners of the roof. You can be on residential rooftops, and same thing. If you can get line of sight from one corner of the roof in a high foliage area, but you need to broadcast from the other, it's possible with the solution very, very quickly and easily. So that's kind of the whole idea behind it. And then small form factors and discrete to make it, to where you can go again, street furniture, residential, and not run into any, objections.
Yeah, and it's interesting that those radios are that small and have that capacity and that distance on them. Why don't you describe just a little bit about how far one of these radio links can stretch, or how far from an access point to a subscriber radio can stretch, that sort of thing?
Yeah, absolutely. With 60 gigahertz, most of the people on the call will understand that the rain region that you're in will determine a lot of that, especially Faisal down in Florida. He's going to know firsthand what the rains can do. But so I'd say in the rain zone K, which is probably about 50% of the US, you're looking from a 4-inch radio to a 4-inch radio. About 500 meters is the distance for call it 5.9's reliability, and then about a kilometer to 1.2 kilometers on the 8-inch unit, kind of going in a point-to-point case. For the access radio to those same ones as CPEs, again, it's 400 meters, 800 meters kind of range, depending on which model you choose. The interesting piece, though, is the model that we're enabling. When you look at homes passed in the markets that we're looking at, so if you're passing, again, in this case, 2.5 kilometers, we're passing 1,000 homes. Generally, and especially in high foliage areas, you never need to go that far, right? You can get the density. You can do much shorter hops to overcome foliage, other pieces, and also provide the blanket coverage. So in our view, we don't need to go 15 kilometers to make this work. We've priced it out to where infrastructure sites, CPEs, all of that together, build out a mesh that provides the coverage and everything that you need, and you'll never have to worry about weather with our platform.
Yeah, all great points. All great points. I think I mentioned this to you guys on a call earlier, but I heard the expression in a sales training years and years ago that you don't sell the steak, you sell the sizzle. And I think in this case, I think with your product, the real sizzle, the real hidden gem in your product is the planning software, the LinkView software that helps the operator design the network, do test designs and so forth. I don't want to get into it because Bryce is about to get into it, but really the real beauty of the system, besides these point to multipoint and mesh radios, is the software. So, Bryce, why don't you go ahead and take over? We're going to have a live demo of the LinkView software here. You're muted, buddy.
Yep. Hey, everybody. Let me just share my screen. Okay. So,
And before you start, let me just throw it out to the audience again, or I didn't say it yet. If you have any questions, please post them in the Q&A panel down on the bottom of the screen. Hit the Q&A panel, and we'll take questions on the fly. We can also have some Q&A at the end. So, sorry, Bryce, go ahead.
no, you're good. Okay, so it's been really fun journey working on these products to really help empower WeLink, and now working with other customers like you guys. Like Dan said, we've built this great hardware platform, but needed to build a really powerful software platform to be able to enable the use cases. So I'm going to show you guys a couple of different things that we've put together to make this full kind of complete Ketson package. So the first one is the planning software. So because line of sight is so critical, we go and acquire high quality, high resolution line of sight data so that we can put together a model of what sites can see what other sites. So what you're seeing right here is, this is actually one of the WeLink networks in Las Vegas. I'm sorry, and this one's in Phoenix. And what you're seeing is all these little blue circles are anchor nodes, or nodes that we've looked at because of the line of sight profile. They look like they'd be good fits to be infrastructure nodes. And then all these other circles that are, or the diamonds, I should say, are serviceable customers or homes passed based on this plan. So you can see as I kind of just mouse over things, you can see how we're kind of drafting out where those point to multi-point radios should be in order to cover a very high percentage of this neighborhood. You know, as you can see, as I kind of pan around, most of these homes in here are light blue, and there's few that are, you know, this darker color, which means that they're not serviceable. So this would be a great plan if we could build to this. And this works really very well with a WeLink deployment model, which is using customers' infrastructure. But we could use anything. We could use towers. We could use street furniture. We've done that, those type of deployments also, where if we just know those locations, and if we get the line of sight profiles for those utility poles, then we're able to develop a plan just like this, all algorithmically, that picks out the best way to design a network. So related to that, some of the kind of the nuances that we've worked on with a deployment model, a go-to-market strategy like WeLink's, where customers are infrastructure, is if you look down here in the south part of this market, these green sites are ones that are already installed. So these are live customers. And in order to meet kind of the rest of this network plan, we would need to go and sell particular homes in order to contribute to the mesh and keep building out this plan. So you can see these little orange nodes in here are ones that are sellable. In other words, we built a very lightweight sales app that looks like this, that a sales rep would look on their mobile phone and they would see these nodes, and they would, you know, could basically go out and start the sales process. They could go in and mark the disposition of that particular home. And if the home is sold, it gets locked into the plan, and then it opens up the next homes to be sold. But if they're not interested, then we kick that home out, and we can actually rerun that planning algorithm within a couple seconds or a couple minutes, so that the sales rep can keep having quests and can keep working to build out the plan. So really cool how these software products kind of lean on each other, fit together to help build out a network. So the next part that I'll show you is, if, you know, we've already planned the network, we've sold the network, and now it's time to install. So let me show you some of the tools for technicians. So if I was a technician and I had this, you know, let's say this new Leaf customer that needs to be stood up and installed, we've put a lot of work in to make this a really quick and efficient process for this Leaf customer. So the first thing I'll say is that all the configuration data is generated automatically when that customer gets marked as sold, and it gets added into this NMS software that we built called LinkView, so that you don't have to have a network engineer do anything to add the new site. You don't have to have even a laptop. All you need is a mobile phone, which is what I'll show you now. Is I'll I'll shrink my browser so I'll show you what a technician would see as they get up on this roof and they see kind of this checklist of site certification checklist of all the things they need to do in order to be ready to complete the install. And notably, this one-touch provisioning is something we're really proud of, where they just look on the radio, see the MAC address, put it here, hit save, and then when that device shows up on the cloud with that particular MAC address, then the cloud will push down all the configuration data so they don't need to key it all in or have the risk of fat fingering any of it. So the process is plug in the radios and then, put in the MAC address, and then we have this aiming map that helps them kind of pick which AP they need to, which AP is going to be best. In this case, I'm pointed at this one over here. But if that one didn't work, I could also go down this list and see, oh, there's actually other access points that I could point to if the first one doesn't work. And we have these in a prioritized list based on a lot of different information, like the distance and how many other clients are connected. So really powerful tools that basically let a technician get right up on the roof, aim in the right spot, get the devices provisioned all online in very quick order. The kind of like overarching objective that we've worked with many of our customers is that an anchor technician should be able to get about 2 installs per day, and someone doing leafs or the client sites would be able to do up to 4 a day. So that's kind of our rule of thumb of how fast we want them to be able to deploy.
And Bryce, I recall from a previous presentation that you guys have a fairly wide beam width on these radios, right? So the guys who are used to point 60 gigahertz, who are trying to aim a radio within a half degree of azimuth, you don't really have that problem, right? Because your radio is a little wider than that.
Yeah, go ahead, Chad. You may want to get in the specifics of the hardware capabilities, and I while you do that, I'll pull up this aiming map.
Yeah, the 4-inch radio, it has a kind of I call it like a principal field of view of 10 degrees, both horizontally and vertically. It uses a 5-degree beam, but it does beam steer to basically account for a 10-degree field of view. The 8-inch is a little bit narrower. It's a 2-degree primary beam. And it beam steers to about a 4-degree field of view. The access points are 120 degrees, as you guys can kind of see within this visualization here that Bryce is showing.
Yeah, so the technician just has to get close, and then he can use this screen of his app that Bryce is showing to kind of tune it in, right?
Yep, absolutely.
Yeah, thank you, Dan, for bringing that up. And we're coming back to, like I was saying, the metrics of trying to be able to help technicians be able to do quite a few installs per day, and what are the tools that can help them get dialed in as fast as possible. And so this is another thing that we've developed, is this aiming grid, where basically you can see here that it's updating a couple times a second what the signal strength is. And we actually are telling them if this one's aimed pretty well, but if they were off, this grid would tell them you need to come down into the to the right or up and to the left to basically help them get dialed in really, really quickly with near instant feedback with this updating a couple times a second. So yeah, plug in the radio, get a signal, and then you're just swinging this radio until you get it dialed in, and then you're off and onto the next one.
Right, and that's all using the app, because a lot of the 60 gig radios will come with like a little mini telescope thing, and it's they're just difficult to aim. Installers won't have that problem with your product.
Yeah. The next thing I want to show you is just the NMS capabilities, the network monitoring system that we've built for our customers. So you can see here I'm looking at a network, and I have the capability to kind of filter things out if I just want to see things that look good, or if I'm trying to find troubles in the network. Like I can look at things that are degraded, which means that they're experiencing some kind of issue, but they're still online, but there's some problem. And I can get a lot of details on that customer and figure out what's going on. So in this case, you can see that there's something going on. It's degraded. Right off the bat, I can see the speed tests are looking lower than expected, and there's a low ETH port speed. So you know, doing a lot to call out some of the problems in the network. Let's poke around for another second and see some other ones. Like if I want to look at something that's critical, so something that's even worse, these customers are going to be offline. I can come in here and I can see they're worse. We do have some speed test results, but I can also see that devices are offline. And there's a lot of like detailed information I can see, like when it went offline. In this case, they weren't experiencing any packet loss before they went offline. I could see that data transfer was working. I could see the speed test looked pretty good. They were getting, you know, close to 2 gigs up and down before things went offline. So in this case, this is probably looking like a power issue or something like that. What I can show you, the last part I'll mention on this is that we have a lot of these very detailed alerts to help resolve really as many types of issues as we come across. So I think there's 50 different alert types that we will surface to try and like narrow down the root cause and get customers back online quickly. So this is just part of the software package that we're just scratching the surface on that we built on top of the kits and hardware.
Very good. That's great. And you kind of mentioned the zero touch provisioning, but can you go into that in a little more detail?
Yeah, I'd be happy to. So let me show you an example here. So especially with one of the infrastructure sites that has a more complicated config. So if I take a look at, I'm just picking a random one, for example, and if I come into the technician view for this one, and if I just come down and look at the config, so this is all the data that's required for provisioning. You can see there's a lot here: DNS, mesh area IDs, domains, NTP servers. You know, there's a full page of specific details that obviously need to be right. You can't fat finger any of the things in this screen. And when we push the config, as soon as they put in this MAC address, that's all the data that's getting added, is everything that you see in this configuration screen that helps the network speak securely to all the other equipment that or its adjacent peers, I should say.
And then
Yeah, and I'll add a little bit of color to that. So obviously a lot goes into planning deployment. So what Bryce had showed you guys with the planning tool. So once you confirm that you've sold a location, it's going to be an anchor or it's going to be a CPE site. The link view piece, when you convert that into a site and lay out the wireless configuration, it's going to build the bill of material for you. And it's also going to take the rules that your network engineering teams have set forth to create all these configurations. So the SSIDs, encryptions, it also is doing all the channelization. So it will look at the channel usage across the network and making sure that you're using the correct channels to make sure you're not self-interfering. So that's one of the key pieces of going to scale is one, technicians don't have to learn any of this, any of the IPv6 or any of these settings. They don't have to worry about it. They have to be able to do the physical build work and use the app on their phone. The network engineering team does not have to get involved at any install unless there's a debug. But in general, like the network engineering team can be focused on bigger picture issues and setting up infrastructure for future builds. And then warehouses, there's no pre-configuring anything of the like. So it's really getting those technicians to move quick.
right, and then touch a little bit on redundancy or not redundancy, but redundant links and alternate routes and so forth. So I know you have a really resilient design as you add more and more of these nodes to the network and you can add routers to the network. Go into that just a little bit for us.
Yeah, sure. As you can see here how a typical mesh is laid out in that you can see that there's a lot of redundancy just in the structure that came out of our planning software. So for example, if any of these anchor nodes were to go out, then the traffic would automatically reroute using the OpenR protocol within less than a second to a route that is still open for communication. And I'll let Chad jump in. He may want to add more.
No, so I'd say OpenR is the underlying routing platform that runs within the mesh itself. And we do that because of the scale and the automations that are there. If you guys haven't heard of that before, it's maybe not surprising, but it was actually the same platform that Terragraph was built on top of as well. So Terragraph took the OpenR platform and then implemented it onto a chipset, and specifically a Qualcomm chipset. So we looked at the OpenR and saw the value of it, but then didn't tie it to a single wireless system. We felt Peraso was the best fit for us, and so that's why we went that direction. But yeah, so it's doing the hello messaging on a session by session basis to find the best path through the network. So using waiting, latency, and several other metrics throughout those hello messages in the key stores, it can basically load balance between one or multiple fiber or injection points that you guys set forth within your backhaul.
And Dan, I wanted to throw in one more thing as we were talking about technician efficiency. There is, let me see if I can open this up here. Yeah, we actually just deployed an Android and iOS app that will help technicians find the rooftop or basically the other side of a link, where it actually deep links from our app right into this native app that's both Android and iOS that puts this big pin in augmented reality so the technician can be up on the roof and can jump right to and see, oh, that's that direction. That's where I need to point to the other side of this radio. And we've actually shared this with the WISC community and starting to get some good feedback from people that aren't even using Ketson equipment, but are also needing to do this type of aiming, that they're getting excited about this.
Very cool. Very cool. I think we're coming up close to the end here. If anybody has any questions they'd like to throw in the Q&A panel, we can get those answered for you. No questions. Everybody had a heavy lunch, I guess. Okay, I guess we can wrap it there. Is there anything else that you'd like to say? Any closing remarks you have?
No, well, I guess maybe one, Dave. Obviously, going in and doing fixed wireless at this scale, we've done it with multiple operators now. So we really, would love to have active engagements and chats with you guys on what it would take to kind of grow to these levels. So, turnkeys, contract, how would you even look at door to door? Is door to door the right fit? I mean, there's lots of this that we would love to be actively engaged with you guys and help learn how to grow.
Yeah, we found you guys to be very much involved in the sales process, and we appreciate that. I thought of something else that we didn't discuss too, from an RF standpoint. You guys use the entire available 60 gigahertz band, right? Some of which is not as subjected to rain fade as other parts of that band.
Oxygen fade, yeah, but yes. So yeah,
Oxygen.
we do operate in the upper channels and the lower channels together, so we can get out of that oxygen, which allows you to go further. But we still have to account for the rain and the planning tools that Bryce has built in. So as an operator, you guys can say, this is where I'm deploying. These are the SLAs that I want to offer. So I want to do 1 gig speed plans and I want to have 4 nines reliability. It will then basically, going through all those planning stages he shows, it'll hold everything within the checks and balances to make sure that we use all the channels, maximize the distances and in your ROIs.
And it also takes into account the rain zone that you're in?
Yep.
Okay, so you'll end up with longer links in the desert Southwest than you might in the Midwest or East Coast.
Yep.
Okay.
And it models snow and ice as well. So we can look at just about anywhere nationwide, well, worldwide, and be able to deploy.
Very nice. All right. If there's no other questions, we'll go ahead and wrap it here. If you want to learn more about the Ketson products, please contact your CTI sales rep. You can reach out to me as well, and I'll redirect you. And then for any of you folks that are going to be at WISP America, the Ketson folks will be with us at WISP America as well. So hopefully
We'll be
we'll
at
see you there.
FISPA too.
And sorry.
We'll be at FISPA too in New Orleans if anyone's going to
That's
that.
right, at FISPA too. Yeah, that's only a couple of weeks away now. So yeah, we'll be at FISPA in New Orleans and WISP America in Oklahoma City. All right, thank you all for attending. Send an email if you have other questions or call out to your CTI sales rep. Thanks very much.
Thank you.
See ya.